Not least, we have Shaun. I know we're running a little late on time, so probably 10 more minutes and we'll get you guys out of here. Zen Management, Jay gets the award for being actually on time, so thanks, man. Let's see how time does.
And what's your title?
Alright, so I'm going to talk about robotics. I was clapping when Michael said they were going to get more women involved because this room is overflowing with women compared to a robotics conference. So there's definitely a need for more women in robotics and technology. So let's see if I can go back. All right, so I'm going to present on the ROS Industrial Program. It's an open source robotics library that Southwest Research has released, and it's kind of my baby. I started ROS Industrial about 2 years ago, and now it's kind of a global open source program. We're still growing, but there's a lot of excitement, and hopefully that comes through in my presentation. All right, so I'm a robot programmer, and you probably thought that was the coolest job in the world, or at least I did when I decided I wanted to do this. And it really is. It really is the coolest job in the world. But what you really find is that you're not on the cutting edge of technology. When you program industrial robots like I do, you're really on, I don't know, the cutting edge of 10 years ago. And basically the reason is you got to do what works. You got to do what's reliable. If a robot goes down on a factory line, that could be $100,000 a day that they're losing, right? So you basically stick with what's safe. There's problems with doing that though, and that's what we were trying to address when we started the ROS Industrial Program. So down there in the bottom right, that's what I actually do as a robot programmer. And I'd love to tell you that little gizmo over there is a dated photo from like 10, 15 years ago. But that's actually called a teach pendant. That's how you program robots today. That's how every robot on the factory floor is programmed. And yeah, it's an old piece of junk, actually. They recently upgraded it, though, because now you could get a color screen. That was the big upgrade. So, and it turns out when you think about programming, that's not what we're doing with industrial robots. We're really using that teach pendant to kind of drive the motors individually and then record a point. And then the robot memorizes that point and it can go back and forth to it all day long. It's robust, it's reliable, it's boring as hell, right? And if you're trying to do anything, the least bit dynamic, if you would like to do what a robot really should do, right? Develop some true artificial intelligence, do something dynamic, you're limited by the tools. You're really just frustrated, right? So frustration equals opportunity, right? If you're pissed, fix it. All right, so frustration isn't a good enough business model by itself. So it does help to take a step back and say, why does this problem even exist? You know, there are powerful tools out there. The lamp stack is a good example of just powerful open source tools. Why aren't they leveraged in robotics, in industrial robotics in particular? Well, there's definitely, this leads to like a core problem, I guess, in the market. And this graph kind of illustrates that, which is when you talk to people in robotics, they tell you, this is our growth area right here. We're going to grow that, right? Because if robots are truly flexible, then we should be able to do lots of jobs with robots, not just welding and material handling. But as you can see, in the past 20 years, their growth area hasn't grown at all, right? And there's a reason for that. It has to do with the software. It has to do with the fact that you're so restricted in what you can do that if you have to do anything slightly dynamic, which includes a lot of those other kind of activities, it's impossible to do. So software truly is the limiting factor. Market structure is also kind of contributing cause. So if it were just software, they would just download the lamp stack, put it on a robot, and then they'd be doing really cool things. It's not that they don't know those things exist. It's that there are 12, probably a dozen different robot vendors in the world, and none of them are very large. So they don't even have the scale to even attack this growing market problem, right? And they're just happy with the market that they have. It's fine. They can service their customers and they're good. So really, it's not a technology problem. We know what technology solves this problem. It's really a market problem. So if we take a step back and so there is one solution to this. The market could consolidate. All these different robot vendors could come together and consolidate into a couple of companies. But that hasn't happened in 10 years. So when you look at it, open source is a solution to this problem. Where you have this incredible frustration. People want to do really cool things, but they lack the tools to do it. And then you have this lack of scale. No one company is really big enough to implement these tools and enable their users and developers to do cool things. It's really a recipe for open source. So the ROS industrial software, it really brings this dynamic ability to industrial robotics, the ability to see, think, and act kind of in an intelligent manner. What you guys probably expect robots already do, but the reality is they don't. And so the ROS industrial takes powerful tools in the open source world and applies them to industrial applications. And at first we were just showing people, here's what's possible. And they got really excited when they saw what's possible. And now we're saying, okay, now let's get together as a community, all you individual companies, all you end users, and let's support this because we think this is truly the solution to that problem where we truly don't have flexible robots. We can't grow our market, right? So, why is this important? So I'm not in a startup. I work for Southwest Research. We do contract R&D, right? People pay us to do R&D for them. So why on God's green earth would you create an open source software package and give it away to people, right? That's your secret sauce. Well, at Southwest Research, we like to say we don't have any, we don't have a marketing department. I'm not entirely proud of that, but this is our marketing, believe it or not. Like when we say, hey, use our ROS industrial software, you can go download it. That's our calling card, right? People do download it. They go and they look at the GitHub repos, they see what we're doing, they see the kind of things we can produce, right? This is the way engineers market. We're the best that we can anyways. We also create consortia. We bring together a lot of different industries and we run several consortiums at Southwest Research. And now we run one called the ROS Industrial Consortium. So it's a bunch of industry, partners, end users, robot vendors that come together and say, the ROS industrial software is important and we're going to support it. And we manage that and we help, with that we help run the ROS industrial program. And finally, when we're out there selling the ROS industrial open source software, that's our market, that's what brings in our actual bread and butter, which is contract-based R&D. People see what we can do, they see the leadership role we've taken in the community, and they say, I want that company to work for me. I want Southwest Research to work for me because they started this really cool idea. None of that helps anybody in this room, right? How does Southwest Research make money? I'm sure you don't care. But there was rationale behind it. So how can you guys benefit from something like this? How can you help me? Because if you can benefit from ROS Industrial and you submit code to ROS Industrial, that really does help me. So industrial startups is one way. We put a lot of code out there. The barrier to entry is a lot lower than it used to be. There's the potential for companies to actually start up around ROS Industrial. The Ubuntu for manufacturing IT. So if you're familiar with Ubuntu, it's an open source software OS provided by Canonical, and a lot of people just download it, but the way they make their money is selling services to big companies. And they focus kind of on IT, kind of web development IT and that kind of thing. Well, there's really a missing piece, which is all the software on your manufacturing floor. There isn't an open source alternative for that. ROS Industrial could be one part of that. But there's obviously a lot more. I think that's actually a really good growth area in my opinion. And I've gotten lots of people ask me, hey, can I be, is there room for Red Hat and ROS Industrial? And I think the answer is yes. So, how can you help me? You can help me by using ROS Industrial and making it better and making some money off of it, because then I can point to you and say, see, this is really valuable. It produces value. So this is a technology event, and so I promised Michael I would actually demonstrate some technology. So I'm going to demonstrate the ROS Industrial technology live, and we'll see how well it works. So. Any questions while I'm playing around?
Yeah, Shaun, was open source a tough sell to upper management?
Yes and no. So the way I sold it was the ROS software that we build on was developed by an incubator in San Francisco called Willow Garage. And when I met with them, I asked them about if they were interested in industrial robotics. They said, no, not at all. We don't care about industrial robotics. They care about service robotics. But they were they basically said I could come out and work with them and learn from them and kind of start the ROS Industrial program. But in order to do that, I had to open source it. So when I went back to my management, they're like, oh, we're going to give away a lot of that technology. That's kind of a downside to it. They don't really see the value. They didn't see the value in open source. But they're like, well, we want you to go anyways because we want you to learn from what they're doing. So I kind of sold it as I'm going to learn from these guys, and as a result, I have to open source the software. But it turned out to be the best decision we could have made, because otherwise it wouldn't have gone anywhere. Now there's a worldwide community around ROS Industrial. That wouldn't have happened if we just kept it inside. So, anybody know what this is? This guy right here? It's a Kinect. It's a commercial version of a Kinect, actually. It's meant to sit on top of your PC. But it turns out this is the coolest thing that happened to robotics since robots, right? So using this, we can actually give our robots the ability to see. This is really kind of what drove us, is we want to utilize technology like this, right? Which in the open source community, they hacked the driver in a day. Right? If we had to rely on kind of our industrial vendors to do this, well, it's like 3 or 4 years later, they still don't have one. So the reality is, this kind of technology is enabled by ROS Industrial, and so that's very important. So one of the things you can do is pretty cool object recognition. So I'm going to show off this little capability. See if I can see my bag.
The light on, Shaun?
No, let's do it without the light. Then that proves I'm doing something. Plus, it's plausible deniability if it doesn't work. All right. Okay. So let me bring away the point cloud. Basically, what I did, and you can just download this off the internet. It's at my GitHub account. That's my resume, by the way. It identifies kind of the floor in the scene, and then it identifies objects on that. You can imagine in a factory setting, just being able to identify objects in 3D space and pick them out so that your robot can interact with them is very important. So you can see that it recognized my bag down there, got my foot. So that little point cloud there is my bag, and if I process that just one step further, I can now tell my robot, hey, go pick up that bag. And I bet all of you thought industrial robots could just do this. You thought entire factories, just completely peopleless, were with eyes like this and industrial arms that you're used to seeing, could do this. And the reality is they can't. There's more capability in ROS Industrial now than most commercial packages you can buy for a lot of money.
I know we're running out of time, so we'll take 3 questions and then we'll wrap it up.
Thank you.
We're out of time.
Yeah.
Go ahead.
The prime sense, that was the company Apple just bought.
Yeah, Apple killed it.
They killed it, or they're gonna?
They're probably gonna kill it, right? When Apple buys a company, they don't buy it so that they can sell $150 sensors, right? They buy it for a reason. The technology's still there, though. There'll be other companies that kind of stand out. And there are commercial versions of this that we're aware of that are coming out, 4 years later.
So apart from open source, you said that this technology or the ability to identify an object and pick it up is not existent at, say, at Ford's factories. Why is that?
Part of it has to do with that reliability, right? So especially at a company like Ford or GM, they have one line, right? They have an assembly line. It's just one line. If a robot has a problem on that line, that's the end of the world, right? You stop the line essentially. That's very costly. So Ford and GM, they engineer that line so that there's almost no way a robot or anything else can fail. Where this is very powerful is maybe a small company who can't put in all the engineering effort to engineer the process. So maybe they're just boxing candles, for example, and they want to pick up candles and put them in boxes. This kind of technology enables that, and at the same time, it doesn't have to be as reliable, because if your boxing robot goes down, you can just put a person in there. So part of that stagnation that you saw there in the growth is from the fact that there's this whole market of small and medium-sized companies that don't use robots at all. And they aren't addressed at all because the software doesn't really meet their needs.
What kind of programming is it like?
So it's C++ and Python is pretty much what you do. So it's pretty high-end on the programming side. But you're doing complex things, so you kind of expect the level of complexity to be there.
Thanks, Shaun. I said we're going to do some things at the end. I think I'm just going to call it here and wrap it up.